Formal system, Wikipedia audio. A formal system or logical calculus is any well-defined system of abstract thought based on the model of mathematics. A formal system need not be mathematical as such. For example, Spinoza's ethics imitates the form of Euclid's Elements. Spinoza employed Euclidean elements such as axioms or primitive truths, rules of inferences, etc., so that a calculus can be built using these. Some theorists use the term formalism as a rough synonym for formal system, but the term is also used to refer to a particular style of notation, for example, Paul Dirac's bracket notation. Each formal system uses a set of primitive symbols to finitely construct a formal language from a set of axioms through inferential rules of formation. Background. The system thus consists of valid formulas built up through finite combinations of the primitive symbols, combinations that are formed from the axioms in accordance with the stated rules. More formally, this can be expressed as the following. The syntax of a language is what the language looks like studied in formal language theory. The semantics of a language are what the utterances of the language mean. A formal system is said to be recursive or recursively enumerable if the set of axioms and the set of inference rules are decidable sets or semi-decidable sets, respectively. The entailment of the system by its logical foundation is what distinguishes a formal system from others which may have some basis in an abstract model. Often the formal system will be the basis for or even identified with a larger theory or field consistent with the usage in modern mathematics such as model theory. A formal language is a language that is defined by a formal system. Like languages in linguistics, formal languages generally have two aspects. In computer science and linguistics, a formal grammar is a precise description of a formal language, a set of strings. The two main categories of formal grammar are that of generative grammars, which are sets of rules for how strings in a language can be generated, and that of analytic grammars, which are sets of rules for how a string can be analyzed to determine whether it is a member of the language. In short, an analytic grammar describes how to recognize when strings are members in the set, whereas a generative grammar describes how to write only those strings in the set. A logical system, or, for short, logic, is a formal system together with a form of semantics, usually in the form of model-theoretic interpretation, which assigns truth values to sentences of the formal language, that is, formulae that contain no free variables. A logic is sound if all sentences that can be derived are true in the interpretation, and complete if, conversely, all true sentences can be derived. Axiomatic system, formal ethics, lambda calculus, proof calculus. A deductive system, also called a deductive apparatus, consists of the axioms and rules of inference that can be used to derive theorems of the system. Such deductive systems preserve deductive qualities in the formulas that are expressed in the system. Usually the quality we are concerned with is truth as opposed to falsehood. However, other modalities, such as justification or belief, may be preserved instead. Recursive. In order to sustain its deductive integrity, a deductive apparatus must be definable without reference to any intended interpretation of the language. The aim is to ensure that each line of a derivation is merely a syntactic consequence of the lines that precede it. There should be no element of any interpretation of the language that gets involved with the deductive nature of the system. Pawnini is credited with the creation of the world's first formal system in or before mid-4th century BCE, well before the innovations of Gottlob Frege and the subsequent development of mathematical logic in 19th-century Europe. David Hilbert instigated a formalist movement that was eventually tempered by Gödel's incompleteness theorems. The QED Manifesto represented a subsequent unsuccessful effort at formalization of known mathematics. Examples of formal systems include: the following systems are variations of formal systems. Formal proofs are sequences of well-formed formulas. For a WFF to qualify as part of a proof, it might either be an axiom or be the product of applying an inference rule on previous WFFs in the proof sequence. The last WFF in the sequence is recognized as a theorem. Inference and entailment. Formal language. The point of view that generating formal proofs is all there is to mathematics is often called formalism. David Hilbert founded metamathematics as a discipline for discussing formal systems. Any language that one uses to talk about a formal system is called a metalanguage. The metalanguage may be a natural language, or it may be partially formalized itself, but it is generally less completely formalized than the formal language component of the formal system under examination, which is then called the object language, that is, the object of the discussion in question. Logical system. Deductive inference. History. Formalism. Hilbert's program. Once a formal system is given, one can define the set of theorems which can be proved inside the formal system. This set consists of all WFFs for which there is a proof. Thus all axioms are considered theorems. Unlike the grammar for WFFs, there is no guarantee that there will be a decision procedure for deciding whether a given WFF is a theorem or not. The notion of theorem just defined should not be confused with theorems about the formal system, which, in order to avoid confusion, are usually called metatheorems. See also, logic machines in fiction and list of fictional computers. QED Manifesto. Examples. Variance. Proof system.